So, number one, describe in a sentence or two what a rational number is. Armani just said that it was integers, but also numbers between integers. And I'm assuming that you're thinking like decimals or fractions, right? And that's exactly what a rational number is. A rational number is either a fraction or a decimal that's either infinite or either finite or has a pattern that repeats. Now, you guys don't have to copy this exact definition down. Please don't. You want to come up with your own understanding of what a rational number is. Remember, a rational number, inside of the word rational is the word ratio, and ratio is a fraction. So that's what you really need to know, that a rational number is a fraction, it's a decimal. Yeah, it's those in-between numbers that you're talking about. So it's like -3.5 or -3.75. If it's a decimal or a fraction, that's what we call a rational number. Number two, describe what an irrational number is. Anybody have one? A definition of your own? What's up? What do you got? Non-terminating? Okay, non-terminating or non-repeating a decimal that goes on forever, right? Like pi. Pi is 3.14. Okay, yeah, a decimal that's a mess, right? It goes on forever. There is no pattern, there is no repetition, because if there were a pattern or repetition, you could technically rewrite it as a fraction. So my definition right here, and you don't have to copy this down as long as you get your understanding of what an irrational number is. An irrational number is a crazy infinite decimal that has no pattern, it does not repeat. Okay, so like pi is a good example. There's also the number e. Also, you could say the square root of any non-perfect square number. Like the square root of 25 is 5, but the square root of 26 is like 5.07 something something, and it keeps going forever, and it doesn't repeat. So any square root of a non-perfect square number will also give you a crazy decimal that goes on forever that doesn't repeat. How about number three? Give a decimal approximation for the square root of 48. 6.9 is correct. 6.9. It's about 6.9. And once again, where do we get that from? We get that from the square root of 49. The square root of 49 is 7, and the square root of 48 is a little bit less than 7. So what's a little bit less than 7? 6.9, and that's why the answer is 6.9. Now the square root of 72, we need to think about that one. Well, that's in between the square root of 64 and the square root of 81, right? If we think about that, the square root of 64 is 8, the square root of 81 is 9. Now 72, it's not really close to 64, it's not really close to 81, it's pretty much in between. So the answer, or the approximation, has to be pretty much in between. So what's the approximation going to be? 8.5. I mean, anywhere in between is fine, but 8.5, that's pretty much in between the two. So I think that's a good approximation. If you did do the square root of 72 on a calculator, it would give you a crazy irrational number, a decimal that goes on forever, it does not repeat, but it will be really close to 8.5. Anyway, moving on to adding and subtracting integers. This is what we did yesterday. So we started adding and subtracting integers yesterday, and we did that pretty fun card game. I think we'll practice it a little more. On the card game, we called the red cards negative integers, and we called the black cards positive integers, right? We had positive values and negative values, and we were able to combine them. And the easiest way for me to combine integers is to think of having money and owing money. So any positive number means that you have money. Any negative number or a minus sign also means that you owe. Unless you have a negative minus, or a minus negative, I'm sorry. Then you have to change to plus plus even before thinking of money. So number 5, I would say I have $3. The minus sign means I owe $5. So if I have $3 and owe somebody $5, I can't even pay them completely off. What's my situation? You're still going to owe them $2. You're still going to owe them $2. Okay, so how about number 6? What's the answer to number 6? Negative 7. Okay, once again, negative 2 means you owe $2. You owe somebody $2. And then you owe somebody else $5. So if you owe 2 and you owe 5, you're going to owe a total of 7. Number 7. What does this mean in terms of money? You have $3 or you owe? You owe 3. What does this mean? You have. So if you owe somebody 3 and you have 5, you can pay them off. How much will you have left over? $2. You'll have $2 left over. So that's why your answer is positive 2. Okay. Number 8. Could we think of money right now, or do we have to do something first? You have to do something first. What do I do?
Make the positive, the negative inside of the parentheses and positive, and no one before it.
Yep. Anytime you have a minus negative, anytime you have 2 negatives right next to each other, you have to change them to plus plus. So let's go plus plus. So that's really a positive 5 in there. That really means that you have $5, not you owe $5. So what do we have here? We have you owe somebody $3, but you have $5 in your pocket. You're cool. You can pay them off. If you do pay them off, you're going to have $2 left over. So it's actually the same problem as number 7. It just looks a little different. Number 9. What does this mean in terms of money? You owe 3, and then what does this mean? You owe 5. This plus sign, who cares about the plus sign, right? It's like saying I owe 3 and I owe 5, right? So if you owe 3 and you owe 5, you're going to owe a lot. How much do you owe? 8. You owe 8, that's right. Number 10, it's almost the same type of problem. Negative 4. And why is that? Because if you owe 2, remember a negative means that you owe, or a minus means that you owe. So you owe 2, you owe another 2, you're going to owe a total of 4. The last 2 are zeros, you say.
No, 11.
Okay, so 11 is 0 because the minus negative has to change the plus plus even before thinking of money. And then you could say, okay, I owe $3, I have $3. You could pay him off completely, but right there you will be broke. You won't have any money left, right? By the way, if I told you to classify that answer, what would it be? Classify whole number, that's right. Yep. Okay, and moving on, number 12, you change the minus minus to plus plus, you end up with a 4 plus 4, which is 8. And that's about it. Now we need to continue practicing adding and subtracting integers. That will be a significant part of the first test that we have on Unit 0, okay? In addition to classifying numbers and decimal approximations of radicals just like we have here. So all this stuff is going to end up coming out on the first test.